please sit. All right, GM everyone. Welcome to our second day of the Hackathon Bootcamp. Today we're going to start with a bit more technical deep dive so that you understand more how Solana works, that you understand more how you can structure your project ideas better, that you understand what kind of tech we have on Solana, stuff that's Solana specific. We're going to having Leo talking about NFTs. We're going to having Nick talking about blinks. We're going to having Lucas telling you about how you can structure your user journey, your user flow better. And today we kick off with a session we call How Solana Works, so that we can make sure that you have that you understand what's specific on Solana. And yeah. All right, let's start with a presentation about Solana. The agenda itself is about the Solana network first. So I'm going to tell you a bit like, why is Solana that fast? What do we do to make it like, this extraordinary? And then I'm going to tell you a bit about the Solana programming model. What is an account? What is a PDA? How does the instruction and the transaction work? Yeah, and then I will later hand it over to Leo, and he will then kick off with the NFT stuff. And yeah, we just keep it going. So first of all, let's talk about the technical advantages that Solana has. And it's probably two things that you would mention here. The first one is a fast confirmation time. So for example, if you want to send a transaction, you don't want this like take 7 days to be confirmed. You really want this thing to be fast. And also, yes. Or we can maybe do the microphone. Yeah, 1 sec. You can do it? Better? Is it better? Okay, cool. And the next thing is the low transaction fees. Because if you imagine you want to build something on chain, all the time there's a transaction going through, you really need to pay something for it. So you really want to make sure that this is not expensive for the user to do, or at least also for your service, if you would, let's say, cover those transaction costs. And you can really build a solid program out of this. And we can do this on Solana, all maintaining consensus through 5,727 nodes in 400 different locations, 40 countries, and over 6 continents, which is, if you think of it, like kind of a task. And the way it looks is like this. So I did a screenshot this morning. This morning we had 3,336 transactions per second in the network. And what you can see in the middle here is basically all the nodes that were live. And why it's important to have all those nodes, of course, because of decentralization, but having so many nodes on a network on so many places is also a challenge. And how we manage this challenge, I'm going to talk a bit now. So we start with a network overview. Very important, if you, for example, come from the Solana world, you might have heard something about meme pools. A meme pool is basically a pool that has all the transactions coming. So for example, I want to send you money now. I say I want to pay like amount X of transaction fee, and then this transaction will end up in a meme pool. And then the validator goes to the meme pool and says, okay, I want to take the transaction that pays me the most transaction costs, and then eventually your transaction will end up in a block. On Solana, it's a bit different. On Solana, we have our epochs, and in every epoch, we have pre-set the spot in which the next block is created and who can create this block. And the validator who creates this block, or let's say the leader who creates this block, knows already upfront what transaction will be there once. You will see this later when you need a block hash, because we really plan everything in advance. so that we can have all those transactions forwarded to the right amount of time the moment the block gets written. And then the leader can distribute those transactions to the block, and then from this block, it will be distributed to the leaders. So the idea here is that if I know now that I want to send something, I request something called a block hash, and then the leader already knows that this transaction will be for him to write on the chain. So he doesn't have to go to some sort of a meme pool, look first what is the best transaction fee for me, and then start putting it in a block. It's kind of preset already, so it can be fast. The engine for this is called Turbine, by the way. And yeah, we have a consensus mechanism here, and we also have another mechanism which is pretty important to know, and this is the proof of history. So the proof of history basically is a predefined hash. It always takes a certain amount to run through, right? So I know that this block now takes like 45 seconds, let's say. And then I can sum up those hashes, and then I know at what point I'm right now. So therefore, I can take a recent block hash, and I know, okay, I will be in this point in time. And this is used because we have, as I said before, about 6,000 nodes in more than 6 continents, and finding the right time, like knowing what time is right now in a decentralized network, is super challenging. And this is just an easy way to instantly know what time is it all over the world. Okay, so to give you a few takeaways here with this network, I really want to do it on a broader scale here to not confuse you. If you want to deep dive here, of course, we can have technical questions later as well. The key takeaways are, first, we have fast confirmation times, which is super good because you really know what you're building on. We have low transaction fees. We do not have a meme pool because we have leaders that can take care of the transactions. And therefore, this is, by the way, very important, which I didn't say. This also says that we can execute programs in parallel. So basically, think of it, if you want to read something from somewhere, you don't have to change something. So we can have very nice runs in between. So I will tell you later a bit more about it. I feel like I haven't given you enough context to understand this point right now. But parallel program execution is something that you can already have in your mind, because later on it will make more sense. And of course, because we have like those predefined slots with the leaders, we have parallel execution times. We can do many, many transactions per second, which is just good for high performance applications that need lots of compute and transactions. So this is a broad overview over the network. Let's now talk more about the Solana program model, because I think this is more important for you to understand when you start building your first applications and design them. And it all starts with accounts. Anyone knows Linux or Unix? Ever worked with it? Or ever heard about this everything is a file concept? Yeah, great. So in Unix, the idea basically is that everything you have there is a file, and it can be executed and run dependent on the proper engines and stuff that you have. And on Solana, it's a bit like the same. We say everything is an account, and an account can be either executable or not. If an account is executable, it means it is a program or a smart contract, how it's called in other chains. And if it's not executable, it means it is an account that holds the state or the data. So it can tell you how many amount of tokens you have, for example. Accounts can have a unique 256-byte address. This is like this public key that you know. They hold a sole balance because we have a rent system, which means that you cannot just, like in Ethereum, give someone tokens. You really need to create an account because you allocate space on the chain for it, and therefore you have to pay a rent for it. An account can store arbitrary data, and yeah, as I already said, you have to pay rent for this amount. So think of it like there is a validator. The validator runs validations. You now want this validator to store some sort of your tokens, and in exchange, you pay him a rent. And then there's a few basic rules. So everybody can credit Sol, which means deposit Sol in an account, and everyone can read data. So you see the blockchain, there's a block explorer, you can just go there and you can just look how much Sol is on what account deposited or what data is there. But only the owners of the account can modify data on an account or debit Sol. So if you want to cash out or if you want to modify something, you have to be the owner of that. I think makes sense. So no other person can just come in and update your data without having the right to do so. And the way an account looks like is pretty straightforward. We have a key. The key is just a public key that you already know. We have LAMP ports. LAMP ports is the smallest amount of Solana. So if you ever heard the word Satoshi in Bitcoin, LAMP ports is this for Solana. Then we have the data, which is the arbitrary data, which I already mentioned. Some sort of data that you want to store in there. This can be a string or whatever you think you want to store. Then the Boolean, it says it's executable. So as I said before, since everything is an account, you have to have some idea if this account now is a program, which is like a smart contract that can execute and run code, or if it just holds data. So this Boolean here tells if it's an account that stores data or not. And then, of course, there has to be an owner, because as we said before, in order to modify an account or in order to deposit something from there, you have to be the owner of this account. So this is also important. So therefore, you already say that. Yeah, and if this account now says true, is executable true, then we have programs. Programs, as I said before, on other blockchains, they are called smart contracts, and these are programs that can be run and execute code and stuff for you. But this kind of makes them special if you think of it. On Solana, for example, those accounts cannot hold any data, as meaning the state. They are written in bytecode on the chain. So if you ever heard from a person that it's hard to understand Solana programs, it's most of the time because they are stored in a bytecode and not on a human readable code. And you can write them in Rust, in C, in C++, and also in Python. There is also a TypeScript framework coming up, but I cannot tell you what the state is right now, but just to keep in mind. Programs, as I said, are stateless, which means that they do not hold your data in the account. So, for example, if you think of Ethereum, for example, you would have a program in Ethereum, and this program has all the states. So it knows how many tokens each and every one of you has, for example, from this specific program. On Solana, it's not like that. On Solana, your data account holds this information. Therefore, the program itself is stateless, and therefore we can have something called parallel execution, because we don't have a bottleneck where you can check where the account state is. You can just read it through the accounts. Again, you must be an owner for the account to modify it. I think I said it enough. And then, of course, programs process instructions. What does this mean? Well, in the end, it just means like if you have code and you want it to run, think of a serverless function, maybe in another data center, you just execute the code, and here it is basically the program executing instructions. And instructions is basically the thing that tells the program what to do.
Sorry.
Yeah.
Something like Dexspinner program?
Something like what?
Dexspinner, or for another example, like Uniswap, or if you build a swap.
Yes. Yes, a DEX would be a program, yeah. Because it's on-chain, and then you would have a transaction that includes an instruction, for example, exchange Solana for USDC, and then it would execute the exchange. So yeah.
Programs also paying rent?
Yes.
So both account and
Yes. Because also programs, the moment you store them, you eat up space on the chain, and every time you need space on the chain, you pay rent. The term rent is still a term, but right now you can get this rent back the moment you delete something again. So you can reclaim it also. There was another question?
yeah. How big can the program be a single like block?
Huh. Oh, a block. Wait. I have it somewhere. Leo, do you know by any chance?
Yeah, so the
1,000.
as big as you guys want. The only thing is like you need to process more transactions because the limit for every transaction is 1 megabyte. So if it's 1024 bytes. So if you want to deploy a program that is bigger than 1024 bytes, you need to send more transactions. But you can deploy like you can deploy a program that is as big as you want, because you can make the state bigger, like the company.
Yeah, well, the program is like if we think C or C++, is it the compile thing or is it like the source code?
It's just like it's a program that is already compiled. It's yeah, exactly. It's like a binary inside of that, and it just tells you how to execute the code.
Does that answer the question?
Yeah.
Okay. Yeah?
How long does it take to deploy to all nodes in the program? And do you establish that you know that it's deployed on all the 5,000 nodes, that there's no old version executed?
How long does it take until everything is in sync?
Depends if it's like ingested. It's just a new transaction, so like it doesn't take like the time it takes is based on how much priority is you put on this other transaction.
Is it 1 minute or 30 minutes?
No, it's closer to 30 seconds.
So, and do you get something back that you know it's deployed?
Yeah. So you
To all nodes.
yeah, sorry.
So basically, then all nodes have the newest version and there's no old version. Do you get any information like on this?
You have only one program ID, and you can like in the program ID is your account, so you cannot run an older version of the program because everybody's like the account is still the same. So when you upgrade or update your program, you deploy to the same account, and so it's impossible to use an old version because
Maybe I'm not clear. There's 5,000 nodes and 5,000 nodes have the old version.
yeah, it's the like you always take the like once I deploy the program, it's like every node's already because it's called in my program. So every like it's impossible because like Solana has DB that is shared, and when I change something in the DB, the other node needs to fetch that right.
So basically, right. So all the 5,000 nodes have kind of a copy of the program.
Yeah.
Yeah.
And if I deploy now, right in a second, then the first node gets an update. All the 5,000 other nodes, they won't get an update in the same second.
Yeah, because it's going to fetch for the from
Should I get kind of a message, okay, now news version is running on all nodes, or do I have just to guess?
No, as soon as it's deployed, it's up to like every node is up to date because like it's like you don't like there is the leader schedule, so like the leader always have the up to date. It's like you're not upgrading all 5,000 nodes because the database is shared, but it's just the leader that is processing the transaction that is taking inside of the.
Okay, thanks.
No problem.
Okay. So I think this answers the question. Never thought about it, by the way. Thanks so much for asking. Yeah, just to come back. So key takeaways, everything's in account. All accounts hold all because we have this rent, obviously. Accounts can store arbitrary data. This is up to you what you want to write in there. Accounts can also store executable programs. And accounts are passed into programs. And therefore, you can run parallel executions. Let's talk a bit more about this, because yeah, there's a stupid question, please.
So I'm just wondering, because the point to the chain is kind of more effort than just deploying to one screen. And I'm just wondering, maybe I'm totally wrong, but how should I decide what I put regarding further work logic on the chain and what should I put on my central server? Because deployment to all the nodes, I think it's more effort, it's more complicated, I have less space, so I shouldn't put everything on the chain, right? So do you have some decision points where you say, okay, just this stuff is really important that I can imagine. If I want to save something for public use, then I should use the chain. But what program node should go to the chain and what not?
Okay. Okay, so the question is, how do you decide what to put on chain and what is basically off chain, right?
Yeah, my feeling at the moment is don't put anything on chain because it's complicated.
Yeah, and space on chain is expensive as well.
So what use cases really require I have to put something on the chain? Because my basically for all use cases, I have my mind is basically just put some states on the chain and nothing else, no program. Maybe there's some, I can say if you have a DAO, of course you need some stuff to organize the DAO, you need to have it on chain. But for use cases we are thinking today and now, not everything is a DAO. When should I put a program on the chain? Maybe I like fantasy or just to have some, that I have some good examples. Because we're not here to everyone, nobody wants to do DAO overnight.
Yeah, I mean, I think it's super hard to say that, because I mean, every implementation is different, and this is in the end something you have to decide. It's your design choice. Some stuff clearly makes no sense to put on chain. Other stuff does, right? So I mean, it already starts if you think about, you don't have to go too far. You don't have to think like of a full program. It already starts with an NFT, right? We say, okay, I do have my mint there, and then this mint, all the other data, all the picture, and this is already an object that I put somewhere on IPFS, for example, because I want to off-store this. And then with the stuff, this is coming up, like CK compression, this idea came even further, where we say, okay, we don't even want to have our associated token accounts and the full account on chain. We rather want this to be on the ledger and then only have like a super small footprint on it. So the whole idea is to save the space of a chain and make it as little as possible, because it, on the one hand, saves you rent. And on the other hand, it also helps like in every way possible. If you imagine you're a validator and you have the state normally you have like is for the last 3 days. And then after those 3 days, you pass this information to a history node. But for these 3 days, you really have to have the state there, which means all the programs, all the accounts, everything that is deployed has to be there. Therefore, a Solana node is like a super heavy machine. It's not comparable to like a normal machine that you would think like, okay, I can run this on my computer. It's like a super heavy thing. So the less you can have on chain, in the end, the better it is. So your choice should also be like this, but also in the way, like, does it have to be? So there's some things like it makes total sense to have it on chain, like you say, maybe a proof, maybe all those basic transactions that go from A to B, it's good that you have it on the chain. But if you think of, do I really have to have like a picture on the chain for my NFT? No. And there's better ways to store it. And then if you think it further, you could even say, okay, what makes sense to have it on IPFS, or should I have it on S3 bucket, for example, right? Because you already have this Web 2 and Web 3 kind of angle that you also have to decide. So in the end, I think it is a super complex idea that you have to break down and then see, okay, I want these components to be on chain because it makes a lot of sense. And then on the other hand, you can say, okay, but for the rest, I don't really care that much.
With assets that are when you interact with assets that are on chain. So if you want an escrow contract for any assets that are on chain, that makes sense to bring that on chain. If you need a marketplace where you want to pay with
transfer with stuff that's on-chain, exchange it for stuff that's on-chain, then it makes sense. If you just want to save data, use a database, because then the user experience is a lot better. Don't use a PDA to just save data that you can also save on a database. So
I would make it more simple. I would say once you need to publicly access data without the entity who did all this, then you need to put it on chain. It doesn't matter if it's states or programs. Once
exactly.
needs to access it without the intermediary, which is
Exactly. If you want fully decentralized programs, then you have to put everything on chain in the end. But I think for the most use cases, there is at some point you have an intermediary in there, the company that is building that. So if you have that anyways, then make use of that and put something in a database to make the user experience better, and then do the stuff that's really valuable, like the assets, put them on chain.
Basically, this is understood to basically put everything in out, because again, it's a hell of work. The question was, I gave really good examples, when you should do us as well, when should you put out stuff on the chain, because again, it's just complicated.
Yeah,
Yes.
and at some point, if you would think, I mean, if you think it through, right? If everything would run on chain, it would also be like super expensive these days still. Even though we want to have everything running on chain in the long run, it's like always a lot of money still. And the tech that's out there these days, it's just like already scalable and out there. So there might not be the use case to do it right now on chain. Yeah. Okay. Let's continue. Yeah, continue with program instructions. What is an instruction? Well, an instruction is the smallest, yeah, let's say, set that you can have, and you wrap it into a transaction. So if you ever thought that, okay, I'm sending a transaction right now, then think of it like, okay, this transaction has multiple instructions that are run simultaneously, that are run in order. And once they're all executed, then your transfer is done, for example. The way it works is you have those instructions. Those instructions have always this structure, as I show you. They start with a program ID. So basically, you have a token transfer program, something like that, or you wrote your own program. This program will have a key, and this key is the thing that you would put in this line. And then it needs an array of keys. The key is important because you say basically, okay, I want to use this account to maybe send money or to update something. So for example, if I would now send you money, it means that you would deposit money from my account. Let's say, yeah, you would withdraw money from my account. So it has to be writable. I have to be the user, the owner. So I have to sign it. And I also have to make this account mutable because you obviously change the state of my account because you will put out money. And then you can have extra data, which is in this data array. And if you have this transaction done, right, there should be also a slide for transaction. Yeah, and if the transaction is done, no, if your instruction is done, you would have those instructions. You put all the instructions that you want into a message, also into this message object here. And this, in the end, is the transaction. So basically, you don't think a bit like SAP here, right? You have this one SAP, and you say, okay, I want, if I send you a message, I want this message to be stored in a database. Let's say this is the first step. This is your one instruction. And then you have like a transaction which is like a multi-step SAP, where you can say, okay, after this, I do that and that and that, and then you kind of put all those instructions into one thing, and this is your big step. So this is basically a transaction. It can consist from one instruction, but it can be more, of course. And then there you would say the block hash, because we already had the thing with the leader that we have for the validation. And then we have a fee payer. The fee payer is the one who actually pays for the transaction fee. And then we have signers. And the signers are basically all the accounts that are used for this message to go through, for this transaction. So imagine the way it works. You basically have your transaction now done. You send this transaction out. this transaction is sent to RPC. RPC is basically the entry point of the network. You can think of it like if you ever did a stream with a VPN client, for example, this is basically your RPC client, so the entry point into the network. And then the RPC sends this transaction to the network where it's going to be sent to the next leader. Yeah. So takeaways from the transactions and instructions. So programs are invoked by instructions because we have the program ID, which we just said. Instructions are sent via a transaction. So if you think of a SAP or maybe even like a package, right? You have a package, the package has stuff in it, and then you just put those instructions into the transaction package, and then it's getting sent out. Transactions are atomic, which is a really important thing, because imagine you have several steps. So I send you money, and then you send me some other NFT back as an exchange or something like that. And this should all be in one instruction message. And if at some point something fails, you don't want me to send you money and then I don't receive whatever we just discussed. So therefore, atomic means that all those instructions that are in a transaction, they have either all pass, or if one transaction fails, it all gets reverted. So that one of the instruction goes south, that all the stuff that was already executed is not in an insecure state. It's just reverted, and then, yeah, it's like nothing happened. And transactions must be signed. Signing means that, for example, you take your, in a way where I would send you something with my wallet, it means that I take my public key, my private key, and I just sign this transaction to tell, okay, I'm the owner of this and I really want this. And then we have custom program data. Custom program data is something that is a bit more specific for the ecosystem that we have here in Solana, because we said already the programs are stateless. So imagine you would have a Web 2 application, and then this Web 2 application has to read some data or write some data into a database. This is kind of doable with the Web 2 applications, but on Solana we already understood now that we have accounts, and accounts can be executable, aka programs, or can be accounts that hold data, and a program itself cannot hold data. So how can my program now write into a database and update data about myself? Let's say I want to use a Facebook app and I want to create a profile there, and then out of the sudden I have to create an account. But since my program is stateless, I have to find a way where I can store this data. And this is called a program-derived address, or a PDA. So the idea is that you have a program, and this program has to store some data about myself. But since programs are stateless, I cannot really store this right into the program. So what the program actually does is, you can think of it like it creates a wallet for me, and this wallet can only be accessed through the program, aka a PDA. And in this wallet would be all the data stored for the specific program. And the cool thing is the program can just do it. They don't need any private keys for it. They can just use a thing we call a seed. And the seed is created the way, I mean, basically you can create a seed the way you want it. So let's say we have a table, like a profile table, the way it would be in a normal database. And then what you would do is you would say, okay, I create now a seed, and the seed is a hash. So I decide what I put in there, and then it will all the time point on the same direction. And here I would have like a profile table. So I call this thing profile, and I added my wallet address, and then it will hash and point right to the PDA that I need. And the cool thing is that it's deterministic. So all the time I put in the same stuff, it will always point to the same wallet. And therefore the program can always point to the right wallet that I need. In a more advanced example, you would maybe also add the profile address. So let's say you have additionally posts, and I already have a profile here. Then I could also use my profile address and my seed to create the seed, and then basically find all the posts related to me. It's a bit hard to understand the concept. Normally, this is where it really takes some time to get your head around it. It's also hard to explain it for me right now, as I understand. But yeah, in the end, just think of it, since a program cannot have its own state, it has to create some sort of a wallet that only it can access, and this wallet holds your data. And therefore, yeah, it needs to have a program-derived address for that. As a takeaway, we say accounts addresses can be derived from seeds, which means like all the stuff that you put in a seed, it will then be hashed and point to this specific wallet. So you always know, let's say if I say, okay, I have profile as a string and I add a public key to it, it will always point to my wallet. Then PDAs can be used to relate data across accounts. It's also very important because sometimes you need a program to do something for you. For example, if we have some sort like a swap on a DEX or so, you need the DEX program to execute everything for you. So you kind of have to park your funds into this vault. And then also PDAs don't have private keys. It's also very important because if you think of it, if I would be able to get a key to a PDA, it means that not just my program can use those funds and access them. It would also mean that I could out of the sudden access funds from another user. Yeah. And I think this more or less, yeah, I can do one more example. So let's put it all together. There's a super easy program on Solana. It's a counter program. So the idea behind the program is the program itself creates a PDA for you. It has a count. And every time you have a function that you call, and then it would increment this count +1. And the way it would work is you have your client. The client is basically the user interface that you use. Then it will send a transaction, in this case, the increment transaction to the RPC client. The client sends this to the validator. The validator then triggers the program, and this program would then use the PDA to update the count by 1. Correct. Yeah, I think this is so much. This is it so far. Is there any questions? Yeah.
In the previous slide, where is the count variable stored?
The count variable is stored in this PDA. So imagine you have the program here, right? This one here. So the program itself cannot have a state because programs are stateless. So you have to find a way where you can store the value or the state of this count, right? And therefore you have those PDAs. So it would say, okay, I want to increment my counter. So let's say I have a seed. The seed is count plus my private key. And then the seed plus my private key would point to a wallet that has a state with a count. So therefore the program always knows that if I, with my private key plus the, if I create a seed, if I have the same seeds that I put in, it will always point to the same program that I have, right? Let's say the data, the account. And then it knows that it can update it by 1. Make sense?
Yeah, so PDAs are data storage things, and they are on the chain.
Yes, they are all accounts. The only difference here is like, okay, if I have my wallet, and then my wallet has funds, and I have my private key pair, and then if I want to send funds, I sign it with my private key pair, right? And then this transaction goes through, and because I have signed it with my private key, they know, okay, this is the valid transaction. But now I have a program, and I ask the program to update a state. And the program itself has no private keys because it only has a seed phrase. And in order to create the seed, I have to put in those increments. And yeah. So the whole thing behind the PDA basically is that you have to store the seed somewhere, the state somewhere, right? This could be also a blog post from me or something like that as well. It doesn't really matter. And if you would have your So if I have my program, right, and you have your counter, we both have an own private key, right? So the seed, the way I would build it is I would call it counter plus your public key. This would be what I put into the seed. And then it would point either to my program or to your data store, right? And then this program can update it, but still be stateless in the same way because the state is held in this place here and not in the program itself. Make sense?
Yeah. So on the chain there are PDAs, there are programs, there are just wallets, I guess, or not wallets, but transaction.
Yeah. So it's accounts, right? So your account is either your private wallet, or it's an executable program, or it's like a PDA. But the moment, think of a multi-sig wallet, okay? So let's say I have a multi-sig wallet like a Squads, and I have 5 keys that are allowed to sign, and I say 2 keys have to sign to get the transaction through. So to build this, I obviously need a program because I cannot do it with my own wallet. I need some sort of code and software that runs over it and does all those checks and does execute the transactions. But this program itself would always look the same, even though I have funds stored there, because my stuff that I store is in my PDA. So the program creates a PDA for me, and then this PDA holds all this logic, like these are my 5 private keys that are allowed to sign, and my rule that if I have 2 signatures, then I can transfer the funds, right? So this is all stored here in this account, also my wallets and my coins and everything, my tokens. Yeah? It's a bit different, I know, because in Ethereum, it would be probably for every token I hold, I would have 1 program, and then everything is different. But here, it's really the case that because those programs are stateless, you have to store a state somewhere. And the program is the one that can execute it, right? The program should be the one that can update the state. I should not do it. The program should do it in behalf of me. So therefore, I need a place where I can store this state, this information. And this is the PDA in the end. More clear?
Yeah.
Okay, cool. Any other questions?
So you essentially store everything in the PDA, right? So you cannot directly interact with the wallet through the program. You need the account where you store the information of the wallet, and then it goes through the account, and then you interact with the wallet. Is that right?
In this case, yes. Yes. So always imagine who's accessing the data, right? So if the data is already on my in my wallet, and I want just to send a basic token transfer out of my wallet, I don't need it. But if I need something that should be controlled by the program, I need a PDA to hold my data.
So in case of multi-sig transaction, you have to store all the information on the account, and then you'll be implementing that in the program, right?
The program will write it in a PDA.
Or modify that one.
Mm-hmm. So it's basically an account, like your wallet as well, but it does not have private keys. So it's not me signing a transaction and sending it out like it would be in my wallet. It is the program executing something on my PDA that it kind of, accesses it, updates it on my behalf. Yeah. It's actually a really important concept on Solana. And this is also the concept that takes most to grasp in the beginning. But once you got it, you can do really, really cool stuff out of it with it. Like, it's coming. Believe me, it's coming. Yeah. Any more questions? Nice. Okay, then I would say we do a 10-minute leg stretch, and after this, we're going to have Leo telling you about the basics of writing programs. No, writing, not programs.
Basic also.
Yeah. rustless coding on Solana. All right, thank you.